All right, Algebra 1, here we go. Continue on with solving linear equations. We've been struggling with this in class for a number of you. I keep trying to relate it back to the same format every time, so we're just going to keep working at it until we get it right, okay? We're going to step up the problem, look at another little twist here and how to solve these problems. They just keep getting a little bit tougher, but hopefully I'm trying to show you one little thing that you can do to get those equations right back into those two-step equations that we've been solving. And we're still struggling with that. Okay, we need to keep working at it. We're getting there, little by little. Let's just keep progressing. We're going to look at solving equations now where the variables are on both sides of the equals. Okay, and our essential question is, well, how do you do that? Okay, basically, okay, because you have x's, let's say we'll talk about x's on both sides of the equation, you can add or subtract those x's from either side. If I have a positive 2x over here, if I subtract 2x from both sides, it'll cancel here, and I can combine the x's on the other side, and it'll turn into a problem, a two-step equation, just like we've been doing. Okay, and then once you get to that, then just solve it. Remember, we're doing opposite operations. Okay, we're working the order of operations backwards, so we get rid of addition and subtraction first, and then multiplication and division. This past week we've looked at little tricks we've had to do to get us into that situation, whether distributive property, combined like terms on the same side, what have you. And now we're just going to look at variables on both sides, and I'm going to work in those other things too, just to kind of refresh your mind. So here we're looking at a problem, and this is in the book. You can follow along there too. It's 5x plus 2 equals 2x plus 14. You notice we have x's on both sides. Okay? One thing I'm going to try to be the same about here is I'm going to add or subtract my x's to one side so that I end up with positive x's on one side. I like to work with the positives. I think the negatives kind of mess you up. And when I look here, 5x is bigger than 2x, so what I'm going to do to move it over, just like we've been moving other things, I'm just going to subtract that thing. And notice I put it just with the x's because you can only add and subtract like terms. Okay? Some of you keep forgetting that. So what that does for us now is it cancels out here. 5 minus 2x is 3x plus 2 equals 14. That takes us right back to our two-step equations that we've been solving now for 2 weeks. This you should be getting pretty good at. Okay? We've got an addition problem. Again, order of operation in reverse. Get rid of addition and subtraction first. If you are adding something to your x side here, do the opposite. Subtract it from both sides to get rid of it there. So the 2's cancel out. Now I'm sitting here 3x equal to 12. I've got a multiplication problem now, so now I'm going to divide out the 3 to get x by itself. Remember, that's our goal. X is equal to 4. You can always plug it back in and check it. 5 times 4 is 20, plus 2 is 22. 2 times 4 is 8, plus 14 is 22. 22 equals 22. So we got the right answer. Okay? Again, you could subtract the 5x over, but then you're going to get a negative 3x here. That messes you up sometimes. That's why I subtracted the 2 over. If that had been a negative 2, I would have added it. Okay? But it's positive, so I subtract. Then I get down here to a two-step equation. There's addition, there's multiplication. I do the opposite operation, adding and subtracting first, so I subtract the 2, then I divide the 3 out. It's the exact same thing I've been telling you now for 2 weeks. Okay? Let's just keep doing it. 5 times the quantity 5, or 2 times the quantity 5x minus 1 equals 3 times the quantity of x plus 11. Okay? So, just like we did earlier in 2.2 or 2.3, we do the distributive property first in both cases. 2 times 5x is 10x minus 2 equals 3x plus 33. Just doing the distributive property. Okay? I've got x's on both sides. 10x is bigger than 3x, so I'm going to subtract my 3x over. Okay? I always like to do that first. Is there another way to do the problem by not doing that first and still get the right answer? Yes. Okay? But I like to get the x's together first. That way it's a two-step equation. Okay? So when I do this, I get 7x minus 2. That cancels out. It equals 33. There's my two-step equation. I've got a minus 2. I want to get rid of that first by doing the opposite, so I add 2. Oops, I get 7x. That cancels. 7x is equal to 35. Then I got multiplication, so I'm going to do division. Divide out the 7. X is equal to 5. Is it correct? 5 times 5 is 25, minus 1 is 24, times 2 is 48. 5 plus 11 is 16, times 3 is 48. 48 equals 48, so we're good. All right? Distributive property, add or subtract over to get your x's on the same side. I like to do it this way, so I get a positive right here, okay? And then add and divide out. Do the opposite operation. Get rid of adding and subtracting first, then get rid of multiplication and division. Now, again, we've got m's on both sides, but we've got these two here, okay? Just like we did it in the last video I did, we combine like terms first. So I got 9m minus 4, and this is on the same side of the equals, so I'm just going to take negative 3 plus 12, and I get 9m. Okay? I want to get my m's together. They're both 9, so it doesn't matter which way you go. In our case here, they're going to cancel out. I'm going to get 0 out of both of those. I get negative 4 equals 5. Okay? We talked about this a couple weeks ago. This can never happen. Negative 4 can never equal 5. What does that mean? No solution. Okay? There isn't a number you can plug in for m and solve this. Okay? If I had gotten negative 4 equals negative 4, then we would have had infinite solutions. You could plug in anything for m and it would have been true. But when it does this, there's no solution. Okay? Whereas up here we got one solution, there's no solution for this one. Okay? Big things here, combine like terms, they're on the same side. Notice I didn't try to add the 3m over here. It's on the same side of the equals. Just combine like terms. Okay? 12 minus 3. And then I subtract it over to get them on the same side. And in our case here, they canceled out. Okay? So there's a couple of examples that tie in some of the things we've been doing, as well as talking about variables on both sides. Just add or subtract it over. Do the opposite operation. Get them on the same side. And then it becomes a problem like we've been doing for the last couple of weeks. We got to get better at this, because this stuff you're going to use all year long in here. You're going to use it next year in geometry. You're going to use it a lot in algebra too. So we got to get this right here. It's a biggie. Okay? So we'll keep working in class. Keep doing what you're doing. We'll get there. All right? We'll see you in class tomorrow. Have a good one.